This is the Amp Hour Podcast. Released June 25th, 2018. Episode 379.9. An interview with Dominic Spill.
Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Dominic Backstory of Great Scott Gadgets.
Welcome, Dominic.
Thank you.
We are still here at Tour Camp. I don't even know what show this is going to be at this point. This might get posted like 3 months from now. Who knows?
It's fine.
Yeah.
Whenever.
So, Great Scott Gadgets, you have been, so we talked to Mike Osman with Jeff Kaiser, and he was talking about Creme Brulee. It sounds like that's been a large part. You are the execution arm.
Yeah, I spent quite a lot of time. It was really two of my colleagues, Jacob and Taylor, did most of the work, but or most of the work on the development and the design of the sous vide system and all that. But it's in a sort of supporting role, helping them with firmware and test cooks and eating a whole lot of custard and things like that.
Right.
But after
my arteries are just filled.
Right, exactly. Yeah. And then after they gave their presentation, we suddenly realized that it dawned on us all that we had to cook 700 of these things for everyone at camp, and like, wow, we thought we were done and we could relax, but no, I've spent most of the weekend with a blowtorch in my hand, grilling sugar.
There's worse ways to I guess, but
yeah, it's been fun. It's been a great way of meeting everyone at camp because everyone's come to get one. So
yeah, that's cool. Well, let's get your backstory. So, I mean, you and I have known each other for a while, but you've been working at Great Scott Gadgets for a while now, right?
Yeah, about 6 years now. 6 years next month. So I started out. Should probably go back to I studied computer science as an undergrad, and my very last year I had to find a project and a thesis, and that was trying to build a Bluetooth sniffer. This is back in the very early days, and my supervisor said, "Have you tried one of these software-defined radio things?" And this was before the HackerF existed, before any of the other kind of modern ones.
Ubertooth wasn't out yet.
This way before Ubertooth.
Yeah.
And I wrote some code. I struggled through it for a year. Wrote some code, uploaded it to the web when I graduated, and went off and forgot about it. And a year later, I get this email from this guy in the US who says, "I've been trying to get your code working, and I've got some patches and things." And we start collaborating as an open source project. And he says, "Hey, I want to go present at this HackerCon. Do you want to come?" And so I flew to DC and I met him less than 24 hours before we gave our first presentation together.
Nice.
And we kind of practiced, and luckily it worked, and we realized we liked working together, and so we kept collaborating on this for a while. A bit later he designed the Ubertooth, and once the company was up and running, he gave me a call. I was living in Australia at the time, and he gave me a call and said, do you need a job? I was like, well, anything's better than working in finance. So I jumped ship and went over to Great Scott Gadgets, and I've got to work on so many fun projects since. But yeah, the first one was maintaining Ubertooth and that Bluetooth sniffing code, and then working with HackerF and SDR and things like that.
So what does it look like? So Ubertooth's been out for, oh man, so many bad puns. I was going to say it's getting a little long in the Ubertooth.
Oh.
Yeah, real bad. My bad.
Yeah.
So what does that look like for you? So the software side, is that low-level firmware or more computer side, like actually when it's plugged in?
Yeah, it's a mixture. So my responsibility tends to be both firmware and host code, but Mike has a software development background, so he writes some of the firmware. What tends to happen these days is Mike will come up with a concept, he'll go and design a board, and or maybe Taylor will design it, and they'll build a prototype. We'll get a couple of OshPark boards, build a prototype, and then it lands on my desk, and I try and read data sheets and convert them into code.
Got it. Yeah.
But for some of these, Mike will. So for example, the Tour Camp badge, Mike already had some firmware that he'd written, and then we tried to build badge flashing stations out of our Great Fet product, and I was working on that code, and so it's everyone in the company wears many hats because there are so few of us.
Right.
But most of the software development comes across my desk.
Cool. So what does it look like? So you see that there's a chip on board. You see there's a register set in the. Maybe let's just start with that. You see there's a chip on board. You open the data sheet. Then what?
So that's a good question.
Because that's like a true architecture standpoint. I mean, hopefully they'll ask you, what do you think about this chip? But maybe you don't get that choice. I don't know.
Yeah. this isn't always the way it works, but a sort of sample of how we go about designing something is someone will find something they want to hack on, or will find a chip that looks interesting. We'll hear about a chip that's been released that looks interesting, and historically it's been radio things, so Ubertooth, Yardstick One, that sort of thing, and HackerF. But we'll find a chip that looks interesting. We'll say, okay, how can we use this in a usually security application, like reverse engineering, that sort of thing. And then Mike will come to me and say, I'm thinking of designing this board, and this is kind of how it's going to work. And we'll decide whether, usually, like, for example, if we're picking an RF chip, like the chip on Ubertooth is a CC2400,
sure,
and that's connected to an ARM microcontroller. And so the question kind of starts off, well, does it have a microcontroller embedded in it? Do I have to kind of build up that tool chain and work that out?
Who's in charge here, right?
Right. Or are we adding it to another microcontroller?
Yeah.
And that's actually where the Great Fet project came out of, because we wanted to play with these chips, so many different sort of RF chips, and we wanted to do software-defined infrared and things like that. Yeah. And we needed a base platform for all these, and we decided a single common base platform that we could iterate designs on top of very quickly.
Right, so you're building tools for building tools with the Great Fet.
Exactly.
Right, yeah.
So most of my work at the moment is working on the Great Fet to make sure we've got this really nice base platform so that we can build add-on boards, which we call neighbors, to experiment with new parts and new technologies as they come available, without having that really long development time of, okay, let's go pick a microcontroller to go with the chip that we're picking and design a whole board. We have a standard form factor, and we design a board that sits on top.
Mm-hmm. Great. So what does it look like when there is something? So like a lot of the products they're computer based, right? They plug into a USB port. What does it look like on the host side then? So you have a host computer that's actually interacting with this thing. It's like, what are you coding that in, and then how do you actually set up that interface? Are you like drawing out, like, do you have like a room where you have like red strings going to like photos and like, like...
That is almost exactly what my whiteboard looks like.
Really?
There's a lot of state diagrams and connection diagrams and boxes of things, and you get down this road of architecture. A big problem that I have is trying to design too much before I write any code.
Right.
And I think this is common of a lot of people, especially if you studied software engineering or computer science. You've had it drilled into you that design is everything in architecture. And it turns out with a lot of these tools, the best thing to do is write some code,
hack at it,
and then tweak the code, because it might take me an afternoon or a couple of days or a weekend to re-architect our entire host side software, but I can waste a week by trying to get
it all out
perfect in advance, and done is better than perfect.
Right.
So it tends to be what I often do is, most of our devices are USB based. Yeah. So I just use Python to prototype, depending on what level of performance we need. For HackerF, because we're moving so many radio samples as quickly as possible, we use C, and we just use libUSB on the host, so I don't have to get down too low level. And
that's what I was wondering. So like how much are you digging into the USB stack and like tweaking on that stuff, because that seems like a nightmare of support.
That's actually an interesting question, because in general we use libUSB to not have to worry about the host side USB stack. But recently I was doing some work on the Yardstick One device, and the firmware for that's actually written by a third party. It was someone came up with this firmware for the CC1100 series chip, and then we designed a board around it. And he goes by the handle of Atlas, and he got in touch with me and said, I'm seeing this weird performance under these conditions. And I looked at it, and I spent some time delving into it, and it just looked like we were hitting a strange kind of packet size issue. And it turns out there are all sorts of intricacies to do with how USB works and its error handling, in that you can do things that cause errors, but the host system recovers from them without letting you know. But these look like performance issues from a higher level.
Got it.
And so it turns out you have to send a zero-length packet to terminate a transaction, and we weren't doing that. And I've now found this bug in 3 different USB stacks on 3 different pieces of equipment and three different open source USB stacks. I'm sure it's in all the closed source ones as well, because it's such an easy mistake to have made. So I do get quite low level in the USB side on the host, and in fact I've been working with another software developer called Kate Temkin, and she's maintaining the Face Dancer code that Travis Goodspeed started years ago, and building that on top of GreatFit. And so we're getting really low level in USB things there, because we're able to emulate USB devices and perform kind of proxy attacks on devices. And we have a tool called USB Proxy that sits in the middle of a connection and lets us reverse engineer and modify. And we usually demonstrate this by reversing the left-right steering on a joystick for the Nintendo Switch. So we play Mario Kart, but in reverse and things like that.
Messes people up, and it's fun.
Yeah,
to laugh
it's fun. And we did this at Denver Maker Faire last year, and it was fun because a lot of under 10-year-old kids kind of came up and saw Mario Kart on the screen and thought, oh, I'm going to play this, and then the steering's backwards, and a few of them were a bit confused for a minute, and a few of them like got it instantly. For some reason, it didn't really matter to them, the joystick
brain
backwards.
Plasticity.
Yeah, it just worked.
Right.
And then there were one or two who sort of said, okay, so if I can do that, can I make it so that like my sibling's car doesn't turn at all, or I can drive faster, or something like this. And
you just slip my card, you're like, give me a call in 10 years.
Yeah, exactly. I think Mike refers to it as having the evil bit set.
Yeah, right. That's nice. Nice.
And so
in Dover they call that, they're like, ma'am, I'm sorry, your son has the knack.
That's exactly it. And so we, it was fun to see how various people thought about that, and kind of inspire the next generation, because I don't know about other people, but so many people I went to university with got into computer science because they wanted to write video games. Yeah. And I think that's how I got into computers originally when I was a child, but at some point, like, low-level communication protocols just took over in my brain. And I haven't played a video game apart from backwards Mario Kart, I haven't played a video game in years, but I'm always, anytime I see two devices communicating with each other, I think, I wonder if I could interfere with that in some way.
Got it.
And so that's mostly what we end up.
So you have the evil bit, you're saying?
I think it's pretty well confirmed at this point. Yeah.
Good.
So
British supervillain. That's good.
Yeah.
It's got the you got the accent for it. You're ready to go. Yeah.
Yeah, exactly.
Yeah. That's cool. So you're low level in these stacks. What do you usually expect people to interface with then? So like people that understand the HackRF, that's usually talking to something like Canoe Radio, but it doesn't have to. So
right. So we have. We try and enable, on the software side, especially on the host PC side, we try and enable as much flexibility as we can. So the really nice thing about the time HackRF came out was that there was this explosion in SDR. RTL SDRs appeared a couple of months before HackRF was released, while it was still in development. There were some other higher ends,
Blade RF,
and then things like Pluto have come along later.
Right. When USRP was what's the
USRP USRP is the ETIS board, and that was the board I first used, the original USP. I think mine has a 2-digit serial number. It's that early, and I really should give that back to the university. And
oops.
Yeah, and so they've had various different models, and it was really nice actually, because we know various people at those organizations from Canoe Radio conferences and things like that, and it was a very shared experience for a while of we're all trying to expand the same market, like there's plenty of room for people to use all these different things, and but we wanted flexibility, and the Canoe Radio project, which is the kind of higher level DSP project, they wanted to support as much hardware as possible, and a group called the Osmocom, who were working on reverse engineering GSM systems and building open GSM systems, wanted to support as much hardware as possible. So they wrote this abstraction layer, and that's what we tend to do. Is we write some low-level, very specific code for our hardware. Then there's an abstraction layer on top of that, so that anyone can speak to it. And there are a couple of these, and they exist in multiple languages. So you can. You've got Canoe Radio with C and C++, and then SOAPy SDR, which is Python-based, and it just means if you want to tinker with a HackRF and then switch it out for an RTL SDR or a Blade RF or whatever, your code should still work. And that's something we like doing, because it makes the development experience much more flexible, and it means people can pick up our hardware and put it together with someone else's code without me having to be involved in writing a driver or an abstraction.
Yeah, right.
That.
Well, let's walk down the stack then from like a Canoe Radio. So we've talked to Derek from Canoe Radio. So from Canoe Radio, what are the steps to get all the way down to the actual RF level? Like how many layers are there?
Wow. So in Canoe Radio, you'll have a signal source or a sink, and that will talk directly to libHackRF, which is our C code. that I maintain, and along with Mike and some other people.
So is that through Osmocom though, or is that?
That is through Osmocom, and usually it's the Osmocom block within Canoe Radio.
Okay.
So you talk to Osmocom. Canoe Radio talks to Osmocom. Osmocom talks to libHackerF. libHackerF talks to libUSB to do USB transactions.
Perfect.
And then that's all done through your operating system's kernel.
Sure. Yep.
And the reason we use libUSB is because it's cross-platform, and it means that one set of code. Hopefully,
you don't have to deal with the Mac or the Linux or Windows crap, right?
And it makes life a lot easier. And I develop on Linux, and that's where a lot of our users are. But it does mean that it's possible for someone to build Windows binaries for someone who wants to use Windows.
Yep. Which opens the market, really. I mean, like from a sales perspective, that's almost necessary from a hardware.
And it's really nice that I don't have to spend too much time trying to work out the Windows development environment, because I just...
I'm not writing any DLLs, huh?
Right, keeping that in my head alongside the Windows environment, and then if I had to work on the Mac environment and so on and so forth, it becomes a lot more sort of complexity to carry in your brain. Okay.
So we'll go through it one more time. So we're at Canoe Radio, Osmocom, to HackRF, libHackerF.
Yep, then libUSB.
Okay, then what's below that though?
Below that's the operating system's kernel. And it speaks to your USB host controller on your system, speaks over the USB bus, and then on the far side, we have, for HackerF, we have, it's called, I've completely forgotten its name for a second, libOpenCM3, which was designed for Cortex M3s, and we added a lot of code to that to support HackerF and the LPC 4300 series chip, which we use on both HackerF and GreatFET. And so we have a USB stack on that we wrote and is part of libOpenCM3 now. Or part of libHackerF as well on the device side rather than the host side. And then on top of that sits a firmware, a single-purpose firmware for HackerF.
Got it, right. And that's actually talking to the chip and activating registers in the chip, and then the chip takes that and then blasts them.
Exactly. So
that's a lot of distance, but I think that's good to have that full stack visualization type stuff, because it's a long way, right? I mean, like,
right. And these are where the diagrams on my whiteboard come in.
Right. Exactly.
How where's this data moving around, and how can we not copy it between memory buffers too often, and get the most performance out of it? And really the one of the things when Mike designed HackerF along with Jared Boone, that they talked about and they discussed is that one of the things they really wanted was to be able to power it from a USB port, not have to have an external power supply, have it small and portable, and so it's USB 2, which means actually the limit on performance is the speed of the USB bus and how many bits we can get across that. And we talk about USB 3 once in a while and looking at parts, but we have to. When we were designing it, at least, and I think still now, there were almost no sort of integrated microcontrollers that had USB 3 support.
Right.
And so you need
an
an
stack
external
as well, right? You need the software piece.
Right, exactly. Yeah. So we'd have to have a USB 3 transceiver chip on board, and then a microcontroller, and you've got to have a high-speed bus between those before you go to your high-speed bus to your ADCs and DACs to get the RF section. Yeah. So that adds more complexity and more cost to the board, and we were targeting a price point, and we were targeting kind of being able to just pull the thing out of your backpack wherever you are in the world, plug it in and see what that weird radio signal is. What's that antenna you see over there? What's it transmitting at? And so we were much more interested in wide frequency range and portability.
Yeah, collecting as much as you can and then processing it later.
Exactly. Right? Yeah. And in fact, we worked with someone, a friend of mine from Edinburgh called Mike Walters, who wrote the tool in Spectrum, which is a visualization tool for SDR, and he came up with this idea for a hacker camp in the UK a couple of years ago, EMF camp.
Oh, nice.
And I should plug EMF camp.
I was going to say, that's on my list. You're going this year?
I will be there, yeah. I'm actually, I run the, I'm involved in the organization. I run the speaker operations team on the ground. So mostly I'm making sure people get to
remote
stages.
Too, huh? Yeah.
Oh, it's been interesting being remote this year. Before I'd always been in the same city as the other people organizing, and this year I'm
different time zone,
I'm
different
thousands
spot.
of miles away, and I only take part in meetings via Notepad at like IRC and things like that. But yeah, that's at the end of August. So I'm really looking forward to being back in the UK and seeing everyone. And and attending that
Tell
event.
us about it real quick. Sorry.
Oh, so it's a small
sidebar.
So it's a 3-day hacker camp every 2 years. It runs the same year as Tour Camp. So in Europe there are a whole load of hacker camps in Europe, but the two big historic ones are the Dutch camps, which change their name every 4 years, and the German CCC group run a camp every 4 years, and they're offset by 2 years.
Yeah. Yes. The next Chaos Camp is 2019, I believe.
Yes, that's right.
I found out this week. Yeah.
2019. That's right. CCC camp, Chaos Camp 2015 is probably my favorite hacker event I've ever been to.
Wow.
It was eye-opening for me, and I'd been to Tour Camp. I was at the first Tour Camp, and it's great fun, and I didn't really know what to expect then, and EMF Camp I helped out with a little bit beforehand, and I went to Chaos Camp, and it was just huge, and there was this amazing amount of effort that gone into installations and working on projects with people, and you'd walk around, and I'd come from Vegas that year from DEF CON, and so I was jet lagged, and I was about 3 o'clock in the morning walking around and walked past a tent, and some people were hacking on something, and I just sort of said, "Oh, what are you hacking on?" They said, "Oh, come in, get involved with this giant 3D printer they were building," and it was so open and welcoming, and I loved it, and I feel the same about all the hacker camps now, and you know, we've been making Creme Brulee for the past 3 days, and the number of people come up and said, "Do you need any help?" Someone turned up and said, "Do you need any help?" And I said, "Well, can you separate eggs?" And they said, "Sure." And then, I mean, I think she might run our company now. She's so organized, and like turned up the next morning to help us cook a second batch of Creme Brulee, and just fantastic. And so we. I really like that openness that you get with these, and the fact that they're 24-hour means that there's always something going on, and people working on lighting installations.
Yes, late night last night. I got a 4:30 a.m. Happy birthday call, even though my birthday's not for months. So
wow.
Yeah.
Over the ShadyTel network?
No, this was GSM.
Okay. Okay.
Straight to my line.
Yeah.
Yep. 24-hour.
Yeah, but there's fantastic things going on, like the ShadyTel network, like someone set up a pager network that you can dial to over the network that's on site, which is really good fun. And in fact, we got these pagers from somebody at camp. I don't even know who gave it to me, but someone gave me a pager at camp here, and we were teaching our intern about them, and he'd never seen a pager because it's never been relevant. It's like he was born in the 90s, it's never been relevant in his life, and that's
crazy.
Entirely fair. It's like he's loving it. He's having such a good time with it. He's been sending messages.
Now imagine this is all you had.
Right, exactly.
Go find a payphone.
Yeah, exactly. And trying to. So what you did is you stood next to a payphone and you sent someone you paged someone with the number of the payphone, and they called you. And why would you do any of this stuff? Because cell phones existed from the earliest days that he remembers, and things like that. So that was kind of fun. And reviving these old technologies is always a little bit of fun, especially with SDR and wireless technologies for us.
Yeah.
I guess.
So you guys doing the pager stuff with SDR or no?
At EMF Camp, I don't believe we are, but we do have a GSM network that's going to be running across the site.
Nice.
I don't know how much I can say about the badge, but it may be related.
Whoa, nice.
And so that'll be good fun. The badge team for EMF always put huge amounts of effort in, and the sponsorship team as well. Finding people to sponsor these elaborate electronic badges is a real challenge. So there's a phenomenal amount of effort that goes into it, and it's incredibly rewarding when we get, for EMF, we get 2,500 people on site this year, and we turn up less than a week before everyone else does, and to an empty field, and
it turns into a playground for nerds.
We've got 3 speaking tracks, and
that's great.
Some workshops, and villagers turn up, and so I really like that. The atmosphere, and it's always fun to see what people bring. And even though I get to see some of the content or the proposals for the content before they start, I'm still amazed every time when I get there and someone's built this phenomenal installation of lights and sound, and someone brings along an old arcade of pinball machines and and retro computers and things like that, and it's just amazing what people are willing to bring to the middle of a field to show off for a couple of days.
Right. It's funny when I sometimes when someone's doing something I don't like, I say, like, "Don't you have a hobby?" Like in anger you say that, and it's like people that are doing that kind of stuff. It's like, yeah, they do. They got hobbies.
Oh yeah.
They got hobbies galore. Yeah.
Oh yeah. There's definitely, and it's great to for these people to show off their hobbies.
Right. Yeah.
My favorite little installation piece that someone brings along. Almost every time it was the Dutch camp last year, and it's been at EMF before. It's a pair of wheels, a car battery, and a speaker, and I think a Raspberry Pi, and it takes its GPS position, and it algorithmically generates music. And so for every square meter of the planet, it produces a different piece of music. And it's
like, oh, you're in the bad sounding zone right now.
Right. He charges it up, he puts it outside his tent, and he puts a big label on it that says, "Take me for a walk." And then at the end of the hacker camp, 3 days later, he just goes and finds it. It's a thing making music somewhere. And he finds it, and maybe he recharges it if it's run out, but like he'll take it home and he'll bring it out, and it's this sort of weird, unassuming, it looks like a gas canister with
Why does this exist?
wheels.
And the answer, if you're asking that question, you're asking the wrong question.
Yeah, exactly.
Yeah.
But if you're fascinated that it exists, you should definitely attend a hacker camp.
That's great. That's great. So let's go back to the Great Scott Gadget stuff.
Oh yeah.
So we've gotten all the way from the high level software down to the low level software. I mean, what are some of the challenges you see going forwards with specifically in the SDR space? I mean, obviously you guys are building a lot more stuff. The Great Fed is a new product coming out. What do you see as the challenge?
Yeah, I think it's interesting. There are a lot of people chasing performance, and I absolutely understand that. High dynamic range, more higher sample rates, better RF performance, and things like that. And with open source hardware, that's maybe not necessarily a game we want to get too far into.
Specsmanship type stuff.
Yeah, exactly.
Right.
And we're much more. I like to think of it as the games console model. There's Microsoft and Sony are fighting it out for the highest performance, the best graphics. They'll tell you how many polygons they can put on the stage, and Nintendo will just invent a console that you can take with you and also plugs into your TV, or has these novel controllers, or the cardboard box thing.
Right.
And so I think,
well, actually, the big thing with Nintendo is the software piece, right? It is that other layer of stuff that isn't necessarily hardware specific. It's more about like the overall experience. So
exactly, and so I think that's I personally, and I have no idea if Mike feels this way about the company, but I like to think of us in that space. We're very interested in future products being novel.
Yeah.
And so what I was saying earlier about like wideband having the biggest tuning front-end frequency range, this guy Mike Walters, for a previous EMF camp, he got some steerable UV lasers. He got a big piece of glow-in-the-dark fabric and put it up on the fencing, and then he used the UV lasers to plot the spectrum against it. But one of the things he wanted to do was look at a very broad swathe of spectrum. So we wrote some firmware that very rapidly sweeps our entire tuning range from basically 0 up to 6 gigahertz, taking a small snapshot at a time and moving on. Sends that back over to the host system, and the host system performs fast Fourier transforms on it and shows
so it's
what's
doing like
going on.
Buckets of bits.
Exactly.
And then you do the whole thing at once.
And so you're not
right?
just streaming this 20 megahertz block, you're taking a very short snapshot of one 20 megahertz block, then the next 20, next 20, next 20.
Wow. That'll take a while, huh?
Well, it's interesting. We can sweep from 0 to 6 gigahertz in about 0.75 seconds, and then we go back to the start and retune our way up.
And then it takes a while to draw it, I'm sure, too, right? So
yeah, and so you get a refresh rate with the lasers. It's a bit slower, but with the on screen you get a refresh rate about 1 frame per second, and this gives you a background snapshot of what's going on around you in that entire frequency range. And we run this as ham radio events and hacker events, and the 2.4 gigahertz chunk is lit up like you believe. And
right.
It's always interesting.
Any ISM band probably is pretty lit up, right?
Yeah, exactly. And then any ham radio event, everything below a gigahertz is definitely kind of busy. And you see LTE channels popping up because they're all over the place. They're all over the spectrum. And so you see them popping up. And so that's a novel approach that we have, and that's in our firmware that we ship. And that's the other thing we do is we try to do is like add new features and update the firmware and put out software for. So you're not buying a product and then it's done.
Right.
We release a product when we're kind of ready to release the hardware, and we try to keep thinking of new things for the software to do, and iterate on that. So that's a feature that got added, I think, 18 months ago, and hopefully there are more features in the future that will kind of improve the applications rather than necessarily. You can't change the performance of the hardware.
Sure.
You might be able to eke a little bit more performance out of hardware in general, but
But it sounds like you're saying it's almost not necessary in certain
right,
frames of reference.
Exactly. Right? And you know, if you want to build an LTE network, you're probably not going to buy HackerF to do so. You're going to go and buy bespoke hardware and things like that.
Right.
But if you want to experiment and see where are the LTE networks around me, well, we can sweep that huge frequency range and show you that. And so that's why I think the novel applications and the almost looking for new angles of looking at things, and that's one of the things that Great Fit gains us, because we were able to. Someone said something about infrared to us at some point, and I think it was almost a joke that someone said, "Oh, we could just do software-defined infrared. It's like software-defined radio, but for infrared." Right. And then that thought festers.
Right, exactly.
And then,
earworm, right, or whatever.
Exactly. And so then I find myself with a board on my desk that has an IR transistor and some amplifiers, and it's hooked up to the Great FET light, and it works much the same way that HackerF works, and we're able to look at all sorts of weird infrared things that we didn't know existed, and we gave a talk at SuperCon
in pirate costumes.
Yeah, it was one of those things, sitting around, someone makes a joke, and we're trying to think of names for infrared talks, and repeatedly saying IR until we sound like pirates, and it stuck, and so silly pirate costumes. I had a rental bike from the LA kind of bike sharing program, a traffic light. Twice we've been able to do this. Twice we have put out a call on Twitter before we turned up to an event saying, "Does anyone have a traffic light?" And one just turned up. And I have no idea how we managed this, but
you don't want to know sometimes, right?
Yeah, exactly. I guess it's the power of this community. It's the same thing we sort of put out a tweet a couple of days ago. Does anyone need 700 eggs worth of egg whites? And most of them have gone to various people making omelets around this camp.
Is that what that sign is? So that you had a sign on the door that?
Yeah, exactly. We needed to get rid of them because we only used the oaks for the creme brulee. So
that's why it tastes so good.
Yeah, exactly.
I did not know that. Okay.
Yeah. All the
bad parts,
cholesterol.
The good parts, but they're not good for you, right?
The tasty parts that clog your arteries.
Right.
Exactly.
That stuff's so good.
Exactly. So
I've had 3 now.
Oh
yeah. You're like only 3, huh?
Yeah, I've had about 30. I'm not slowing down.
Yeah, so. Right. That's great. Yeah. Awesome. Yeah, and so a lot of you have other presentations online. Are you guys doing a presentation at DEF CON coming up, or other
Yes,
stuff?
we have a presentation at DEF CON called Revolting Radios, and it's about building radios in slightly non-traditional ways. So again, it's educational. We try and focus more on putting ideas into other people's heads as well, and it's using some fairly novel techniques, or hacky techniques, which are a little bit of both. For example, like using, instead of having high-end expensive clock generating and signal generators for mixing on the radio, using the PLL that just exists on a microcontroller. And how rapidly can we turn on and off that PLL? Can we do amplitude shift keying?
Got it.
Turns out the answer is yes. And can we reconfigure it rapidly enough to do frequency shift keying? And obviously these things are very noisy, and we only do the sort of transmission in our lab environment in a sort of shielded room in the hills above Denver.
Right.
But we have some receivers as well that we'll be able to demo live at DEF CON. So
awesome.
It's going to be good
fun. I'm looking forward to that.
Yeah.
Well, thanks for talking to me here, and we'll have more creme brulee, I'm sure.
Yeah, absolutely.
And I'm looking forward to hearing more about EMF Camp after that's gone off. And
excellent.
Yeah, we'll have more talks here coming to you from Tour Camp. Thanks for being with us.
Thank you very much.